Alright, the last kind of conversion we are going to look at is going from grams of a substance all the way into how many atoms or particles that we have of that substance. And then also how many atoms or particles all the way to grams. We have gone from grams to moles, and we have gone from moles to atoms. So, therefore, since you know both of them, you can go all the way from grams into atoms. So let's look at an ordinary example first. So say that I have 550 grams of jelly beans. And as I mentioned in a previous video, there are 35 grams per dozen of jelly beans. So if I have 12 jelly beans or a dozen jelly beans, I'm going to have 35 grams. And we call that the molar mass. So if I want to go from grams into dozens, I take my 550, divide by 35. And that'll tell me how many dozens I have. Well, when I do that, I get 16. So I have 16 dozens. Then if I want to know how many individual jelly beans I have, I take that times 12, because there are 12 items in one dozen. So 16 times 12, I have 192 jelly beans. So I went all the way from grams of jelly beans to how many were in there without even having to count anything. Alright, so let's go ahead and look at a couple of examples. So how many atoms are in each of the following? And we have two elements, A and B, and then we're going to look at two compounds, C and D. So let's start off with 55.2 grams of Li. So we have 55.2. And then I want to know how many moles are in there, because when we did the ordinary conversion, we went grams into dozens. So I'm going to go grams into moles. So I have to look up on the periodic table and find Li, which is lithium, and find its molar mass. Well, when I do that, I get 6.94 grams per mole. And since I have 55 grams, and there are 6.94 grams in one mole, and I don't know how many moles there are, I'm going to divide. If you're not sure, set up a ratio. I looked at that before. You take your 55.2 grams, say how many moles, equal to 6.94 grams in one mole. So you can always do ratios for these. Okay, you'd still be dividing. Well, then when I get that answer, I would then have how many moles I have. So then when I figure out how many moles I have, then I say, okay, I want to know how many atoms are in that number of moles. So then what I'm going to do is take it times 6.02 times 10 to the 23rd atoms per mole. And then when we divide and then multiply, we should come out with 4.79 times 10 to the 24th atoms of lithium. So why don't you go ahead and try the second one, and then check your answer when you get done. You should get 6.68 times 10 to the 20th atoms of lead. If you did not, check your work, figure out where you went wrong. Okay, now we're going to look at compounds. It's the same setup, you're just going to have one extra step. I'm going to put this extra step earlier. If I have 495 grams of CuCl2, well, before we looked at on our periodic table to figure out the molar mass, but CuCl2 is not on the periodic table. So I have to find the molar mass of CuCl2, and then I divide by that molar mass. So remember, you take one copper and two chlorines, add them up and get your total, which should be 134.45 grams per mole. Divide those two, I'll get a certain number of moles, and then multiply by the 6.02 times 10 to the 23rd. And these are actually molecules per mole. When you talk about a compound, it's always dealing with molecules. When you talk about an element, you're dealing with atoms. So we do this division and then the multiplication. You should get an answer of 2.22 times 10 to the 24th molecules of CuCl2. Go ahead, try the last one here with water, and then check your answer when you get done. Now you should get 1.19 times 10 to the 24th molecules of water. If you did not, look at my work and figure out where you went wrong. Now it's time to go the other direction. Now I want to know how many grams are in the following number of atoms. So now I'm starting with atoms, I'm going to grams. The last part we started with grams and went to atoms. So I take my 7.85 times 10 to the 24th atoms. And I want to know how many moles that is. You always go through moles. You go atoms to moles and then moles to grams. Or you go grams to moles and then moles to atoms. Mole is always the middleman there. So when I go from atoms to moles, we take that atom number and we divide by 6.02 times 10 to the 23rd. Because there are that many atoms in 1 mole. And I have this number of atoms. So I have just over a mole. Then when I get my mole number, I take that mole and I multiply it by my molar mass. Because I'm going to have some number of moles, and there are 14 grams in 1 mole, and you just get your answer. It should be 183 grams of nitrogen. So you can also set up your ratio if you want, and that will be fine. Just make sure you set up your ratio correctly. Either the atoms on the same side or the atoms across. It cannot be diagonal. Go ahead and try the titanium, and then check your answer when you get done. So you should get 389.6 grams of titanium. What about if you have a compound? Now it's the same thing as before. And we dealt with compounds. I have 1.83 times 10 to the 21st atoms. There are still 6.02 times 10 23rd atoms in a mole, and actually these both should be molecules. Again, since it's the same number, it's not a big deal, but these should actually both be molecules. When I have that number of moles, then I multiply by my molar mass. And remember, since it's a compound, it's not on the periodic table, I have to take each part and add them up. So 1 lead, 1 nitrogen, and 3 oxygens. When I add all of those up, then I multiply by the molar mass, which is going to be 269.21 grams per mole. You divide and then multiply, you should get 0.818 grams of PbNO3. Go ahead, try the next one on the back of the sheet, and check your answer when you get done. You should get 31,300 grams, or 3.13 times 10 to the 4th grams. The last thing we're going to look at for this half of the chapter is going to be converting them from grams of a compound to number of individual atoms of an element in a compound. And we looked at this before, actually, when we talked about converting from molecules of something into carbon atoms, or moles of carbon atoms. So when we do that, okay, you're going to take your number of grams, divide by your molar mass to get your moles, and then we look at the formula. And if it is, for example, say CO2, and I want to know how many oxygen atoms, there are 2 moles of oxygen in 1 mole of CO2. Because there's 2 after the O. So we take that mole number times 2. And we say, okay, now I have that many moles of carbon or oxygen atoms. I take that times the 6.02 times 10 to the 23rd. Because that's how many atoms are in 1 mole. You're doing the extra step of multiplying by however many are in that particular formula. So for example, how many hydrogen atoms are in 4 molecules of water? Water is H2O. Well, if I have 4 molecules of water, and there are 2 H's for each molecule of water, so I have 4 times 2, I would have 8 hydrogen atoms. Works just like that. Let's look at the example. If I have a sample of ethanol, which is C.H it has a mass of 2.25 grams. Don't worry so much about why these are split up. They're split up so that you can tell that it's ethanol, but really it's C2H6O. You can write it like that, and that will be fine. You can combine the 2 H's there. So how many ethanol molecules are present? So that's when we take 2.25 grams divide by your molar mass. So I take 2 times carbon, 6 times hydrogen, plus an oxygen, and I will get 46.08. Then when I get that number of moles, it's 0.0488 moles of a C2H6O. Now I want to know how many molecules are present. So I just take that number times 6.02 times 10 to the 23rd. And then I would get my answer of 2.94 times 10 to the 22nd molecules. C2H6O. Well, we've done that before. The next three ask for how many carbon atoms, how many hydrogen atoms, and how many oxygen atoms. Well, like I explained before, you could take your mole number up here and multiply by 2 or 6 or 1. Or you can do the same kind of thing and you take the molecule number and multiply it by 2 or 6 or 1. So I look at how many carbon atoms. Well, if there are 2.94 times 10 to the 22nd molecules of the whole thing, that means I'm going to have twice that number of carbon atoms. Because there are 2 carbons for every 1 of the whole thing. So we just take that molecule number times 2, which gives us the 5.89 times 10 to the 22nd atoms of carbon. So then when we look at the next two, we take that same number, 2.94 times 10 to the 22nd molecules of the whole thing. And how many hydrogens are there? There are 6. Multiply it by 6, and we get 1.76 times 10 to the 23rd atoms of hydrogen. Same thing for oxygen. What's nice about oxygen is only one O in the C2H6O, so it's just 2.94 times 10 to the 22nd atoms of oxygen. And that's it.